இப்படியே உட்காந்து பேசலாம்ல பக்கத்தில் போனால். Good afternoon to all. It is a great pleasure for me to welcome all of you for this session. On behalf of ISTE Staff Chapter, I welcome our Honorable Secretary Sir, respected Principal Madam, beloved Vice Principal Sir, HODs of various departments and faculty members. The Indian Society for Technical Education is a national professional non-profit society. The one of the major objective of the ISTE is providing quality training programs to teachers and administrators of technical institutions to update their knowledge and skills in their fields of activity. In this regard, we are organizing staff seminar through ISTE Staff Chapter regularly. Today we are organizing webinar on application of recycled concrete aggregate in construction. Our resource person is Ms.D.Shrividhya, Assistant Professor, Department of Civil Engineering. I hope that the session will give good content. Now I hand over the session to our resource person. Madam, please take over the session, madam.
Okay, thank you, ma'am. Good afternoon, everyone. First of all, I thank our respected principal, ma'am, vice principal, sir, and IST coordinator, Mrs. T. Gyanajaya, ma'am, for giving me this great opportunity to deliver my thoughts and ideas. So, myself, Srividhya from Civil Department in King's College of Engineering. Today, I am here to deliver you a webinar series on application of recycled concrete aggregate in construction. So, in this session, we are going to discuss about what is recycled concrete aggregate, where it comes from, and how it is processed, and where the recycled concrete aggregate can be used in the construction site. When we come to the introduction, first of all, we should know why we have to use the concrete waste into the construction. As we know that concrete is composed of water, cement paste, coarse aggregate, fine aggregate, and or it may be made up of some of the admixtures. So here aggregates are very much essential in making of concrete. So here why we are using these kind of aggregates in concrete, because aggregates help the strength of concrete by filling its void spaces and resisting the compressive stress. Using these natural resources such as fine aggregate is nothing but sand, that is it may be a river sand or maybe a M sand or P sand. Then coarse aggregate is a gravel. As we know already, it is made up of boulders. So the consumption of these natural resources is becoming a lot, and it leads to a shortage. Meanwhile, the segregation of wastes from the construction industry goes on increasing. So in this picture, you may see that wastes of concrete. They have simply dumping these wastes as a landfill. What will be the cause of these landfill to the environment? Yes, as the concrete contain cement and many admixtures, it simply emits heat and carbon dioxide to the atmosphere, which will affect the environment hardly. So what will happen if we goes on dumping these wastes into the landfill? Obviously, we are polluting the environment. So as a civil engineer, our work is not only constructing a building, but that work should be environment friendly. Now you will get an idea about why we should use these wastes of concrete again into the construction site. So now coming for the next, Any construction activity that will requires many materials such as a concrete or a steel or a brick, a stone, glass, clay, mud. Mud is nothing but soil, wood, and so on. Apart from these material, a cement concrete usage is more in many construction industries. So to conserve the natural resources and to protect the environment, the utilization of recycled aggregate is very much essential nowadays. So, as I said already, the wastes is comes from demolished structures or in the renovation work of old existing building. So, these demolition waste are disposed of by simply dumping them as a landfill. Therefore, it is necessary to start recycling these concrete wastes, and we have to reuse it again into the construction. Next, the sources of aggregate. These waste aggregates, where it comes from? From the demolition of old buildings or a concrete pavements, even in the demolition of bridges, and it comes from the renovation work or rework due to the structural deterioration, or it comes from the old existing structures. Even the structures are turned into debris. So the debris is nothing but the concrete wastage that comes from the natural disasters. Natural disasters means like during the earthquake, the structure can shake, it fell down. We will get a debris, that is concrete debris, or even in the cyclone and floods also we segregate the concrete wastes. So these are the sources of cement concrete wastes from the construction sites. Next, the procedure to obtain RCA. Here RCA is nothing but recycled concrete aggregate. So recycled concrete aggregate not only contain original aggregate but also has hydrated cement paste. So these should be recycled in specialized work. So next we will see how these kind of concrete aggregate waste can be used in the construction. How it will be used, whether it can be used by processed way or it may be used by non-processed way. It depends upon our usage. In processed concrete, there will be various steps involved in the process of aggregate wastes. So that is, it may be crushing, pre-sizing, sorting, screening, contaminant elimination. So these are the process for obtaining the recycled concrete aggregates. So this process is called recycling. Therefore, further cleaning is also done to ensure the recycled concrete is free from any dirt or wood, plastic, or any other organic materials present in the wastes. So that should be, we have to clean out before going into the usage. Hence, the recycled concrete aggregate contains these process of usages, that is crushing, pre-sizing, sorting, screening, and contaminant elimination, or the process for obtaining the recycled concrete wastes. So, next we will discuss about how the manufacturing will be done for making the recycled aggregates. There will be three major steps. The first one is evaluation of source concrete. The second one is crushing of demolished concrete. The third one is removal of contaminants. So, in the first step, how we should evaluate the quality of source concrete. Here, the quality of waste aggregate can be recorded by its property. How the property will be evaluated is simply by testing the aggregate waste. By various testing procedure, we can evaluate the property of that particular wastes. Okay, so by the test, we will evaluate the property. Like property means the strength of the waste concrete, durability, and composition, that will be compared with the natural aggregate. So these all involved in the step number 1. Next, go for the next one. The second step is crushing of demolished concrete. The crushing of concrete can be done by the jaw crusher or a specialized equipment or a machine with a sharp blender. So here the pre-sizing and sorting of aggregates ranges from 20 mm to 50 mm can be done. This is all about in the second step. Next, move on to the third one. The third process is removal of contaminants from the waste aggregates. So contaminants means uh, reinforcing steel, foundation materials, asphalt concrete. So asphalt concrete means the concrete with bitumen that was comes from the road surface or any other material. We should remove from that waste aggregate before using it into the construction. So these contaminants can be removed either by screening process or air separation, or it may be done by the electromagnetic separators. So in this picture you may see that the process of pre-sized waste aggregate. Thus the size ranges from 20 to 40 mm. So during the process of recycling, the concrete waste was segregated in one side that was contained the sizes also. The screening will be done depending upon its various sizes. So here you will see that 20 to 40 mm sized aggregates are segregating in this site. Here you will see the picture, the demolished concrete block. In the right side you will see two types of aggregate was attained. Here the first one is 4.75 mm aggregate was recycled after the process. In this last picture you see that less than 5 mm and over 0.15 mm, that is 0 to 1.5 mm to 5 mm aggregate or after recycled we had attained. So this is the picture. You may see that demolished concrete is split into by different sizes after recycling. So here the picture shows you that the process of concrete aggregate waste into recycled concrete aggregate. So it is the process how the concrete waste can be recycled after these step of process. So these are the steps involved in the process. First of all, we should collect the concrete waste into this hopper. First of all, you should collect the wastes into this hopper. Further, that will send to the grizzly feeder. Next, the aggregate waste sent to the jaw crusher. Here, where the wastes are crushed. Using the sharp blender of the crusher, the waste aggregates are crushed. Then the magnetic separators will separate the crushed aggregate by its sizes. Here the magnetic separator will separate the aggregate whether to the sizes. The silty and powdery strap will be collected in this iron crop, and the particles over 20 mm will be collected here. Further, it will send to the impact crusher. Again, the particles will be crushed according to its size required. Here, after the screening process, the recycled concrete waste will be collected here according to its sizes. From size 5 to 20 mm of recycled coarse aggregate will be collected here, and the recycled fine aggregate of 0 to 5 mm will be collected here. So these are the steps we are having for the recycled concrete waste. So this chart shows you that wastes or crushes into a crusher, the contaminant will be removed by the air separator or electromagnetic separator. As I told already, the contaminants will be removed either by air separator or magnetic electromagnetic separators. So here the picture shows you that after sieving, the aggregates according to its size was sent to the air separator and magnetic electromagnetic separators. There it will remove the contaminants. So now this picture shows you that the actual image of recycling the large amount of concrete wastes. Here all the process will be involved here, that is crushing, pre-sizing, sorting, screening, removal of contaminants, all the process will be taken place. Here the picture, see the next picture, it shows the specialized equipment machines for recycling the wastes of cement concrete debris. So next is the applications. The application of recycled concrete aggregate, where we can use these recycled concrete aggregates. The following list shows you that uses of recycled concrete aggregate in the construction site. So see here the number 1 and 2, 3 shows you the road surface. The recycled concrete aggregate will be used in the construction of road surface for the replacement of natural coarse aggregate. So in the road surface we can use these wastes, that is recycled concrete aggregate waste into the road surface. See the next one, number 4, that is ground improvement. Number 4, ground improvement. Uh, the RCA is nothing but recycled concrete aggregate will be used in the ground improvement work also, where the soil is to be strengthened, or stabilization of weak soil. If you want to stabilize the weak soil into a stronger, a strengthened one, we can use these debris, that is recycled concrete, into the soil by laying the RCA, that is recycled concrete aggregate, in the ground surface. So next come for the next one, earthwork. So we can use earthwork also, that is earthwork empactment. Here we can use the RCA that will be filled for empacking the surface. Next, for the seventh one, that is shallow foundation. Here in the picture you will see the shallow foundation. So then RCA can also be used in the construction of this type of foundation. As we know that for making a footing, we have to use natural aggregates for concrete. There we can replace these recycled concrete aggregate. So instead of using natural aggregate in the foundation work, we can use these recycled concrete aggregates. Next, eighth one, deep foundation. So see in this picture you will see the deep foundation, the not only in the shallow foundation but also in the deep foundation, like pile work, pile foundation, or mat work, or pier or calcine foundation. We can replace the natural aggregates by the recycled waste aggregate. The next one, utilities. So whatever the utilities, our usage, so whether you have to construct any culverts, water tanks, or any other concrete block, we can use these recycled. We can reduce other raw materials, usage of raw materials, and also we can save our uh, cost saving is one of the important thing in this usage of recycled concrete aggregate. So in ninth and 10th one, we can use any utilities for our requirement. So any culverts or water tank for any concrete block construction, we can use instead of using the coarse aggregate, fine aggregate. That is, coarse aggregate is nothing but gravel, fine aggregate is nothing but a river sand or M sand, or it may be a pay sand. We can use these unwanted materials into the construction. Next, the concrete can be substructures. Substructure is nothing but underground construction. Even in the underground construction, we can use these RCAs. And in the concrete structure, concrete structure is nothing but buildings. All the buildings that was made up of concrete, we are saying that is a concrete structures. So buildings for industries or building for residential areas, we can use this according to its usages. So the picture here shows you that how the concrete debris is processed into a recycled concrete aggregate, and at last it was again reused it by making concrete blocks. So the picture shows you these are the wastage of concrete blocks. So after recycling, it will be again reused for a construction work. So the picture show how the concrete debris is convert into a concrete product. So next I will show you some of the usage. So these are the applications of RCA into the construction. So let me see one by one. So wherever we can use these RCA in the construction, we will discuss. The first, use of recycled aggregate concrete in pavement block benches for community use. So the first picture show you that this is the pavement block. A pavement block is a road surface. Here the second and third picture shows you that benches for community usage. In the residential area, we can use these type of benches for our usage. So for the construction of these structures, instead of using natural aggregates, we will go for this recycled concrete aggregate. So the first application is pavement block and benches for community use. So next come for the next one. The use of recycled aggregate concrete in walkways and driveways. So concrete walkway and driveway. So here the driveway is nothing but road surface that was used, that was owned by an individual. For our individual purpose, we can construct these type of walkways and driveways. So the first picture show you the walkways, and here it shows the driveways of one individual apartments. So here you may see it is a retaining wall. So we can use the RCA into retaining wall also. So retaining wall is a supporting structure to support another surface, any other surface. Okay. So retaining wall is supporting system. So we use RCA in the construction of retaining wall. So see the next picture, the use of recycled aggregate concrete in road subbase. So as we know, for the construction of a road, the first step is to build a subbase. A strong subbase will lead the road as a good condition. So for the subbase construction, we can lay a usually we laid a coarse aggregate. For instead of using coarse aggregate, the raw coarse aggregate, we can use these recycled concrete waste into the construction. So the picture shows how the recycled aggregate concrete is using in the construction site, in the road construction site. Next picture, asphalt paving. So again the recycled aggregate concrete was used in a asphalt paving. So here asphalt means a bitumen road surface. A tar road surface is a asphalt paving. So here also we can combine the aggregate into bitumen for laying the road surface. So here also the RCA is very much useful for us. So we can go for the RCA without any restriction. So in Norway, the city of Oslo, Solsand area, they have constructed a new high school building. Uh, Instead of using the natural aggregate, they are using the RCA into the construction. So it gives you the better result. They have tested their building and compared with the normal concrete. So the RCA used building was giving a much result when compared to a normal raw natural aggregates. So in Norway 2001 they have constructed a high school that was the concrete is fully they have used these recycled aggregate. So these are the some of the pictures that was constructed by the RCA aggregates. So these are some of the block that also used by the recycled aggregates. So here they have conducted a case study on the Melbourne city in Australia. So this building is also constructed instead of using natural aggregate by these recycled aggregate. The case study shows the result when compared with the natural conventional buildings. So how the properties and has been evolved for the testing the properties of the recycled concrete aggregates. So by the research, it shows that aggregate giving 80% of strength can be used in the construction. So the recycled concrete, the strength should be 80%. So that concrete will be used in the construction. In the other hand, it shows if the replacement increases, the shrinkage and creep also increases because the RCA has less resistance and has higher cement content. So we can evaluate the particle size, specific gravity, water absorption, compressive strength, bulk density. So these are the properties of the aggregates. So we all know that particle size distribution will be done by the sieve analysis. The result gives you the particle sizes. So it will distribute the number of sizes according to the aggregate obtained. The RCA are reduced to various sizes during the process of crushing and sieving, which gives you the particle sizes. After the test of particle size distribution, you will size according to the different ranges of the aggregate. The specific gravity can be done by the pygnometer test. Thus, the RCA should contain uh, specific gravity ranges from 2.35 to 2.58. So, it is the range for recycled concrete aggregate specific gravity. Next, water absorption that can be done by the oven dry method. The water absorption property for RCA will be ranges from 3.5% to 7.14%. So next, bulk density. In this test, they were taking the sample of RCA. It shows the unit weight, and the table shows you that the recycled concrete aggregate properties will be equal to the strength that was given by the natural aggregates. So next, obstacles in use of RCA. Even though we are looking all the good things about one particular thing, it is important to study its drawback also. Even the RCA has many benefits, it has some technical problems because of weak interfacial transition zone between cement and aggregate, which it lead to transverse crack. So the high level of sulfate and chloride contents in RCA, it has some poor evaluations. The current legislation and experience not supporting that much and encouraging the recycling of demolished waste in India. So the lack of awareness, guideline specification, standard specification, and lack of confidence in engineers and researchers, there will be a poor utilization of RCA in construction. So lack of these, we are not using that much of recycled aggregate in the construction in our country. So we should be get aware of these recycled aggregate for the better improvement of the environment. So even though we are looking all the good things in a recycled concrete aggregate, it is also important to study about its drawback. So these are the drawbacks. The main thing is the lack of awareness and standard specification and lack of confidence in the engineers are the main thing for the less utilization of these recycled aggregate in our country. Next, value engineering benefits. So, when replace the recycled concrete aggregate instead of natural aggregates, it reduces the need of virgin aggregate and it produces specification sized also. So, these are some of the advantages. It will be economic based and it reduces the amount of landfill disposal. Next, it eliminates the expense of material import and export. So, from one place to another, the aggregates are exporting or importing somewhere, some places. So, apart from using those raw materials, we can move on for these recycled concrete bases. So next, the main thing is cost saving. A few research studies have shown a significant reduction in construction cost if RAC is used. Whether you are using a recycled concrete aggregate, yes, we are saving our cost. And then not only these advantages, we are also having one of the big thing, it creates more employment opportunity in recycling industry. So recycling is having a many process. that we have seen already. So in that recycling industry, we have more employment opportunities. So these are the benefits of recycled concrete aggregate. So that's all about RCA, that is recycled concrete aggregate. Hope you will understand the importance of recycling and reusing the concrete waste uh, again into the construction, and also we will see the application wherever we can use these recycled concrete waste in a good manner in our construction. So it has many benefits. So hope the future will go for the recycled concrete aggregate by replacing the raw virgin natural aggregates. Uh, Thank you all. Once again, I thank everyone for giving me this great opportunity. Thank you.
Thank you, Srividhya madam, for your informative presentation. This is the time to propose vote of thanks. First, I would like to thank our management and secretary sir for encourage us to organize such programs. Next, I would like to thank our principal madam for giving guidance and support for us. Our wholehearted thanks to our resource person, Ms.D.Shrividhya, for presented very good content on application of recycled concrete aggregate in construction. Thank you, madam. Also, I thank Vice Principal Sir, HODs of various departments for their support. Also, I thank you to all faculties joined here for their active participation. Finally, I thank Mr. Niranjan Samuel for giving technical support for us continuously. Once again, I thank all of you on behalf of ISTE Staff Chapter.